When's Friday?
March 14th.
Oh wait, we will be in here.
Yeah, we will.
Let's go. I'm bringing pizza because pizza sounds really good right now.
But
will it sound good on March 14th? I will, probably.
All right. So if f of x equals 3x squared minus 7x, what's the first derivative of that?
6x squared minus 7.
No, just 6x minus 7. And then what's the second derivative?
6.
Just 6. Second derivative, super easy, right? Nah, not so much. Because we get into the more complicated ones. Okay, it says this is the notation for second derivative. A lot of times it's d squared y dx squared. Okay, basically it says take a second derivative of that bad boy. Well, what's the first derivative? D dx of that bad boy. Well, you got a 5 in front, right? Yeah. And then the natural log puts x to the fifth on the bottom. And then you take the first derivative of this, which is 5x to the fourth. So really the first derivative, if we cancel, is 25 over x, or 25x to the negative first. No, it's x, 25x to the negative first. Now the second derivative is what? There you go. You did. All right, second derivative of this. Well, before we can do the second derivative, we need to find the first derivative. So the 6 is in front. The first derivative of cosine is negative sign. Very good. I missed that. Negative sign of 3x plus 3 times, we're doing chain rule here. So what's the first derivative of the inside of this? 3. So really it's negative 18 sine of 3x plus 3. Okay, that's the first derivative. So second derivative, negative 18 times cosine of 3x plus 3 times the first derivative of the inside. So it's negative 54 cosine 3x plus 3. Okay, you just build your way to it. Oh, 3 to the x. I hate these. I hate these and I hate logarithm ones. Okay, what's the first derivative of that? 3 to the x ln of 3. So then, how would we find the second derivative? It is the... You can do the product rule, but you actually don't have to. This is really out in front, because this is like a whole number out front. Now let's do the product rule. I'm going to confuse you if we don't. Okay, let's do the product rule. So the first times the first derivative of this. What's the first derivative of this? No. There's no variable. That's like a whole number. What's the first derivative of a whole number? 0. Why? There's no variable. Okay, so the natural log of 3 is some number, like 1.04567259. Now, it goes forever. So the first derivative of a number is 0. But I get excited. I'm sorry. I'm excited about calculus. Well, I'm sorry. Ashlyn, you're such a smart young lady. I was just trying to put up to help with my yelling at you, which I guess you took as a put down. Okay. Then what's the second half of the product rule here? Come on. ln of 3 times 3x ln of 3. Oh, 3 to the x ln of 3, yeah. So the answer is 2 ln of 3. Nope. ln of 3 squared, 3 to the x. Or, since it's a natural log, I could put the 2 out in front. Could I? No, I can't. Not there. Not that. I think that's the answer. What cancels? Okay. Okay, so that's second derivatives. Did I write that twice? Nope, I didn't. Yep, I did. Because that's different. All right. All right, now second derivatives using implicit differentiation. And you go, what? Yeah, when there's a y involved, you have to do implicit differentiation. So now doing second derivatives with that. Okay, now, what do you think this is? This is actually the first derivative. So the second derivative is just the derivative of this, which is really easy. So it is? It is? How do you take the first derivative of this? 5 e to the
5y dy over dx.
Now, yep, keep going. If you want to keep going, go. Okay. So that's so far, we're good.
Oh, and then, oh wait. No, I'm confused.
Okay. It's times dy. This is times dy dx, right? Do we know what dy dx is? When you multiply the same base, what do you do to the exponents? You add them. That's the derivative of 5 e to the 5y. That is the derivative of that. All right. That's kind of cool. Let's look at this one. What's the exact value of the second derivative at that point for this function? Let's find out. How do you take the first derivative of that? First derivative.
4x cubed plus 2y dy dx equals 0.
Okay, let's solve that for dy dx.
Subtract 4x and then divide by 2.
Not negative 2y. Mr. Bierschbach just did a... Oh, would you please? Yeah, I was. Yep, I was just making it worse. So dy dx equals negative 2x cubed over y. Okay? Second derivative. We have to use a quotient rule. So it's y times minus negative 2x cubed times dy dx all over y squared. Now, do we know what dy dx is? Yep, so we just take this and plug it in. So it's negative 6x squared y plus 2x cubed times negative 2x cubed over y all over y squared. That must be boring, huh? All right. Here's x, here's y. Plug them in. So it's negative 6 times negative 2 squared times 1 plus 2 times negative 2 cubed times negative 2 times negative 2 cubed over 1 all over 1 squared. So negative 2 squared is 4 times negative 6 is negative 24 plus 2 times negative 8 times positive 16. Follow me on that? Because, yeah, that's a 3. So negative 2 cubed is negative 8 times a negative 2 is a positive 16. 5 by 1. All right. So then this is negative 24 minus 256, which is negative 280. Okay? Yeah, second derivatives, implicit differentiation. Okay? Second derivative, implicit differentiation of that bad boy. That's not that bad of a boy. What do we do first? Quotient rule. Because this is already the first derivative, so the second derivative is just y times 1 minus x times dy dx over y squared. So what's dy dx? X over y. What step did I skip? Oh, she skipped a step. Yeah. Well, she's so smart that she can just... So since we have a complex fraction, we should get rid of it. Multiply both the top and bottom by y. So you get y squared minus x squared, follow me, over y cubed. Implicit differentiation. All right. It would be nice if that was it, but that's still not it. Then we're going to look at just how do we connect limits to differentiation. So what problem does this say it is? Find the first derivative of what? Well, where you see a number like this, that's going to be an x. So it's going to be the first derivative of 7e to the x at 4. Because that's where the x comes in. X plus h minus f of x plus h minus f of x all over h. Okay? So what's the first derivative of 7e to the x at 4? Well, what's the first derivative of 7e to the x? 7e to the x. And if you do it at 4, it's 7e to the 4th power. That's an easy one to start off, just to kind of get you into that. So, f of x plus h minus f of x all over h. What's f of x? F of x plus h minus f of x all over h. So f of x, our original f of x, will be 8x cubed. And we're figuring out the limit at 3. Okay? So what's the first derivative of 8x cubed? 24x squared at 3. Put a 3 in. It's 24 times 3 squared, which is 9, which is 216. Okay? Trying to make you think backwards a little bit. What's this one going to be? What's f of x here? You're really right there, but 4 sine of x at pi over 2. Exactly. So what's the first derivative of 4 sine of x? 4 cosine of x. If we stick in the pi over 2, it's 4 cosine of pi over 2. What's cosine of pi over 2? 0. So it's 4 times 0, which is 0. Okay, this one. This one caught me. I got this one wrong when I tried it the first time. Okay? What is f of x? There you guys go.
Is arc sine how you say that?
Arc sine is how you say it. At 2/3. What is 5 arc sine of x going to be? Well, what's the inverse sine of just x? Because that's all it's here. It's just x. 1 over square root of 1 minus x squared, right? And since there's a 5 out front, we leave a 5 out front. Now, this happens at 2/3. Oh, yeah, this happens at 2/3. So you stick the 2/3 in. So it's 5 over the square root of 1 minus 4/9. What's 1 minus 4/9? Square root of 5/9. What's the square root of 5/9? Square root of 5 over 3. Flip it. So it's really 15 over the square root of 5, correct? Did you see what happened there or not? Because I multiplied by my reciprocal. Can I leave square root of 5 on the bottom? No, so I multiply top and bottom by square root of 5. So it's 15 square root of 5 over 5, which is 3 square root of 5. Okay? All right. Is that it? That is it. That's all we're doing today. So that and the quiz. So yeah. Well, they gave them a chance to get their